Alright, so here we have question 4 of the November 2018 Paper 1 Grade 12 CAPS Math exam. Okay, for question 4, we see this is a graphing question. In the graph below, the graph of fx equals ax squared is given. So that's this one here. And let me just write that down. So f of x equals ax squared. Alright, and it's only drawn when x is less than or equal to 0. So only on the left hand side of the y-axis. Now the graph of the inverse of f is also drawn, right? So that'll be this one. That's also drawn. And we've got the point P, negative 6 and 12. Let's just write down that. The point P is negative 6 and negative 12. And I think that's pretty much it. The R is a point on the other one. Okay, so we have also a point R, which we don't know the coordinates of yet. Now, let's have a look at question 4.1. So 4.1, we're asked, is the inverse of f a function? Motivate your answer. Okay, so if we look at the graph of f first, so this one here, right? We can look at that one first before we decide if the inverse is a function. But because we have the inverse graph, we can also just look at that straight away. But f itself, is this a one-to-one, a many-to-one, or a one-to-many graph? Well, if it passes the vertical line test, then it's a function, right? So if we draw any vertical line anywhere, we see it only crosses the graph once. So the original f is a function. But we can do the same for the inverse. So here's the inverse. It passes the vertical line test, right? Any vertical line anywhere just crosses the graph once. So that is a function. So that's one way we can say it. We know it's yes. Yes, it's a function. Why? Well, we can say it passes the vertical line test, but in general what they want is if the original function was one-to-one, so it passes the vertical and the horizontal line test. So any vertical line only crosses once, any horizontal line only crosses once. So that means it's one-to-one. So we can say yes, because the original function is one-to-one. That's probably the best way to answer it. So if the original function is one-to-one, its inverse will also be a function. Your one-to-one just means each x value only has one y value, and each y value only has one x value. If we look at a normal full parabola, then this is a function. It passes the vertical line test, right? Any vertical line just crosses it once, but horizontal lines crosses it more than once. So it's not one-to-one. So this is a function, but if you look at its inverse would look like this, right? That's not a function because that does not pass the vertical line test. Right, so if it was one-to-one, so let's say like a straight line, or in this case just half of a parabola, this passes vertical and horizontal, so its inverse will also pass vertical and horizontal. Right, so the answer is yes, it is a function because the original function was one-to-one, or is one-to-one. That's the main idea. Question 4.2. If R is the reflection of P, so we want R, which is a reflection of P, in the line y equals x, what are the coordinates of R? Okay, so if we reflect something in the line y equals x, then we can see y just becomes x and x just becomes y, because y is x and x is y. So if we look at P was negative 6, negative 12. Now for R, all we need to do is x becomes y becomes x. So the y becomes our x, so negative 12 becomes our x value, and negative 6, which was the x, becomes our y value. So that's all we do, just swap x and y, because it's the reflection of y equals x. Swap x and y, and this is our point for R. Great. Then we get to question 4.3. 4.3 says calculate the value of a. So we need to calculate that value of a. And we've got a point which we can substitute. So we know the equation is y equals ax squared. But we have an x and a y that we can put in, a point. So y is negative 12 when x is negative 6. Okay, so that gives us negative 12 equals a times, what is negative 6 squared? That's positive 36. Now we can divide both sides by 36, so we get negative a third equals a. Nice. Good, and now we get to question 4.4. This is a pretty short question, it looks like. Question 4.4. Write down the equation of the inverse of f. of the inverse of f in the form y equals. Okay, so let's first start with not the inverse. Let's start with just f. So the normal equation f was y equals ax squared. And we know what a is, so let's actually put that in. Y equals negative a third x squared. Right, now if we want to find the inverse, what do we need to do? We need to swap x and y, because that's the reflection in the line y equals x. That's the definition of an inverse. An inverse is the reflection in the line y equals x. Okay, so we need to swap x and y, so we'll make x equals negative a half, or negative a third, sorry, y squared. Now we need to get y by itself. So first let's divide both sides by negative a third, and that'll give us negative 3x equals y squared. And then we need to take the square root of both sides, so we'll have the square root of negative 3x equals y. But remember, square root has plus and minus in general. Now in this case, we're only working with the negative x values, right? So it's only when x is less than or equal to 0, right? Same as with the original. And we can see it's not going to give us both values. So the inverse goes here. Let me actually just draw that. This is the inverse. But if we had plus and minus, it would also go there, right? On top and at the bottom. But we're only working with the bottom part, so it's only negative root negative 3x. And that is our equation for f inverse, the inverse of f. Alright, so that was it for question 4. Not too bad, just questions on inverses. So inverse is just a reflection in the line y equals x, which means x and y just swap around. And so if we had to find the equation of an inverse, we just swap x and y around and then get y by itself. And that's it for question 4. So I'll see you again for question 5.